I recently installed a hybrid inverter for my solar power system. It works extremely well, but there's one major drawback. The monitoring app updates the system data far too slowly. The data is refreshed only once every 5 minutes, which is simply unacceptable for someone with a technical background like me. To solve this problem, I decided to develop my own solution. The idea is to add an ESP32 board as an intermediary controller. The ESP32 collects data from both the inverter and the BMS, then uploads it to a website in real time for fast and continuous monitoring. This project is still under development and is currently only a prototype. I will provide the PCB design files as well as sample firmware to help you get started. If you have the same inverter and a JK BMS like mine, you're welcome to build this project and test it. Your feedback will help me identify bugs and improve the system until it's ready for a stable public release. I'd like to sincerely thank JLCPCB for generously sponsoring the PCBs used in my projects. Many of my projects would never have been possible without their continued support. Let me show you the easiest way to order PCBs from JLCPCB. First, create an account using the link in the description below this video. Next, upload the Gerber file that I provide. Once the upload is complete, you can perform a final inspection using JLCPCB's built-in 3D viewer. This is an extremely useful tool that allows you to easily identify design errors and preview exactly how your PCB will look after fabrication. Then choose the PCB color, board material, and any other manufacturing options that suit your project. When everything is ready, simply add the order to your cart and proceed to checkout. Don't forget to apply the available coupon codes to reduce the cost of your PCB order. Sign up today and take advantage of these great offers. I ordered 10 PCBs for this project, and the total cost was about the price of 2 cups of coffee. About 2 weeks after placing the order, the PCBs arrived. As always, the PCB quality is excellent. All components are SMD, and the spacing between them is quite tight, making hand soldering difficult. The smart choice is to use JLCPCB's PCBA service to save both time and money, especially since not everyone has all the required components for assembly. For this prototype, I'll temporarily secure the components in place, then use a mini hot plate to reflow the board and align the components into their correct positions. After about 20 minutes, I finished soldering a few PCBs. The component count is actually quite low. The board consists of a wide input buck converter for the ESP32 and 2 status LEDs. Finally, I'll apply a specialized conformal coating to protect the components and improve the board's resistance to moisture. Once the soldering is complete, we'll use the flash download tool to program the board. The programmer is actually another ESP32 development board with the ESP32 module removed, leaving only the CP2102 USB to UART interface. After the firmware is flashed, the ESP32 will automatically connect to the inverter and the BMS then continuously upload the data to the server in real time. There are still quite a few bugs to fix, but I hope everything will be polished within the next 2 weeks. I'll upload the project to GitHub and share the link in the description below this video. Stay tuned!